So much of the work that I've been doing at the University of New Brunswick is involved with understanding this type of corrosion, flow accelerated corrosion. Not only does it have an influence on the radiation field buildup on the piping in CANDU reactors, it also has an influence on the integrity of piping in the secondary coolant.
New Brunswick is a small province in Canada, and UNB is the major university. Most of our staff are graduates of UNB. We have more than 100 engineers. Most of the engineers are graduates of programs at UNB.
This particular type of modeling we do here is actually a mechanistic model that can produce very accurate rates of wall thinning without the use of ultrasonic testing or any kind of other NDE that gives you a baseline for how fast it's actually happening in the field.
UNB Nuclear Group doing fundamental water chemistry and corrosion research. CNER is kind of a link to take that to a production style stage to be ready to have an industrial-based product.
So the IP was generated in Atomic Energy of Canada, and it was brought here for commercialization, where they have now developed, through an ACOA grant, a commercial hydrogen infusion probe.
We always have the focus of industry in our mind. We have that as a direction, kind of a leading light, so that already kind of primes the students to be focused in a little more, I hate to say big picture, but a little more broadly.
The importance to the nuclear plant itself is that the sensors that have been developed can give a direct online indication of things like flow accelerated corrosion or overall corrosion rate of system critical components. So it is of high value to industry to be able to do those measurements online in situ, as opposed to having to shut down and do routine analysis during maintenance outages.
What we've also brought to CNER is industry quality standards, and helping them establish quality standards for commercialization of their software and data acquisition systems.
On taking the research in the university and creating an environment where we can couple that with innovation, and it's the innovation that is tied to the research that ultimately creates value for our industrial partners and our utilities, including NB Power.
Well, I think the future in research in general has a lot of community accountability aspects of things. I think all the funding agencies have demonstrated that in the activities that they've been trying to fund in the future.
UNB and the Centre for Nuclear Energy Research, which is a subsidiary organisation within UNB, do research for Point Lepreau and for the nuclear programme in Canada.
I would say the best part about UNB is that we do have some really great researchers here that have been, intimately tied to industry, and it's a university that's really worked hard to build collaborative relationships.
In New Brunswick, because of the caliber of that university, we've been able to undertake some incredible projects in New Brunswick, including the construction of a nuclear plant and a refurbishment of a nuclear plant.
We'll see more of is more requirement to try to have that engagement with the community and translation of research activities to the community.
New Brunswick Power is on the map in North America as a leading edge utility. Just got recognized as a Grid Edge 20 for innovating and disrupting the electric grid in North America, on the sides of Tesla and SolarCity and others. So I believe that UNB has really caused us as a company to be more innovative and be able to come up with some solutions that nobody would expect from a small province.